Hello everyone, welcome to the course Network Theory, and this is Dr. Satyavani Bandela, Assistant Professor, SR University, Warangal, Telangana. And today's lecture, that is lesson number 7, we are going to discuss supermesh analysis in complex network. In last lecture, we discussed mesh analysis in lesson number 6. We discussed mesh analysis in part A with a simple two loop, and in part B lesson number 6 we discussed with 3 different loops and with the position voltage sources and current sources, and where the current sources were placed at the end, which were not connected in between the loops. Now in this lecture we will discuss deeply the mesh analysis and super mesh analysis difference, as well as we will do some problems on it. Now let's share me the circuit diagram or the properties of the super mesh analysis first. Now see the difference between the mesh analysis and super mesh analysis. The mesh analysis is an application of KVL, but super mesh analysis is also mesh analysis, kind of mesh analysis, and it is applicable based on the current source if the current source is connected in between the loops. Because in the last lecture we have taken this is the simple network that here I am giving. If any current source comes at the end, because which is not connected in between the loops, here we can take the current value which is same as the magnitude of this current, whether that is 2 ampere or 3 ampere. Okay, either we have connected this current source here or here, and this magnitude of currents are equal to the loop current, like we equated loop current to the branch current, where the branch current is exactly a current source at the end, okay, which was not located located in between the loops. Okay, now here the special condition, if the current source comes in between the loops. Let us take this example, and here is the voltage source, resistance, and one current source, and right side here I am taking 2 elements. Okay, so if I am trying to apply the mesh analysis, here I can write voltage across voltage source magnitude V, and voltage across this element is IR, and in our loop there is a current source we are crossing, but we do not know voltage across current source. We cannot write current source, because according to mesh analysis, that algebraic sum of voltages in closed circuit equals to, if you know the voltage across the current source we can write, but when current source is connected in between the loops, and either we do not know that loop current, we cannot write that loop current in terms of current source or the voltage across this current source. In that case we require to apply super mesh analysis. Okay, now you just remember the case, let me share, I will explain in detail. So what is super mesh analysis? So case 2 is a super mesh analysis. Case 1 is nothing but normal mesh analysis. Okay, and in normal mesh analysis, first circuit we have taken with the simple voltage sources, whether the voltage source is connected at the ends or in the middle or in between the loops, no matter, but we can apply normal mesh analysis. Okay, and second case, whether the current source is connected at the end of this loop. Okay, at the end of this loop. Okay, whether current source is connected here or here, and those current sources are equated to the loop current. This is second example problem we discussed. Now third example is, now I am taking this current source, I am placing this in the middle. Okay, now if any, according to super mesh analysis, or the super mesh analysis is applied when current source comes in between two loops, there we need to apply super mesh analysis, and that case here I have written as a case 2. Okay. Case 1 is this one, and case 2 is when the current source, whether that is independent current source or dependent current source, no matter. But if that current source comes in between the loops, there compulsory we have to go with super mesh analysis, because we cannot apply normal mesh analysis for that kind of network. Now let us take one example problem and we will solve that problem by using super mesh analysis. Here I am taking one simple network with simple voltage source and resistance and one single current source. Here I am taking one current source and right side one resistor, one voltage source, and left side another voltage source. Now see, the middle one is current source. Let us take the direction of current upwards. Okay. Now here I am taking the magnitude of voltage source is 10 volt and this resistance is 2 ohm, this resistance is 3 ohm, and here it is 5 voltage source. As we know that this long length is represented with positive plate and negative plate, short length, and minus and plus. These two are voltage sources and this one is current source. Let us take the current source magnitude is 2 ampere. Okay. Now the first step to apply super mesh analysis, identify the loops. Like mesh analysis, identify the loops and represent current with I1 and I2. Now this is the loop 1. I am representing current in clockwise direction with I1, and this is loop 2. I am representing current with I2, loop 2 current I2. Okay. Now what to do during super mesh, how to apply this super mesh analysis. Okay. While applying that, first you have to eliminate this current source. You have to remove that current source from the network and apply at a time mesh analysis in loop 1 and loop 2. See, now you have to redraw the network with, let me take the color red one, and here I am taking the same circuit. This is your network, and here the 5 voltage source, and the left side there is a voltage source 10 volts. See here, I removed this current source. I am not connecting current source in between. Okay, and the remaining part of the network will be the same: 10, 2 ohm resistor, 3 ohm resistance, and 5 voltage source. Okay, now from here to here, in between 10 and 2, what is the current? We already represented that current with I1, and current through this 3 and 5 are I2. Is it right? So that's why here I am representing this part current is I2 in clockwise direction. Okay. Now super mesh is now algebraic sum of voltages in closed circuit equals to 0. This is at a time you have to apply in loop 1 plus loop 2. Okay. So loop 1 plus loop 2 together, algebraic sum of voltages in loop 1 plus loop 2. Now condition is removing current source. Okay, deactivating current source. You have to remove this current source if the current source is connected between the loops. Okay. Now see, here I am applying. Now start from here, and in our direction the first element is 2. Here I am writing 2. What is the current through 2? It is I1. Then after 2, now you have to move like this. You have to jump into the second loop, and the resistance is 3. Now this is plus 3. What is the current through 3? 2. Okay, I2. Okay. Now in our loop, this is your super mesh. Okay. Mesh in loop 1 plus mesh in loop 2 is together super mesh. Now in supermesh, two resistors and those currents are I1 and I2. Left side I have written, and then next right side, in this supermesh, first one is voltage source. We are crossing from minus to plus, that's why it is plus 10. And here in supermesh, we are crossing this voltage source from plus to minus, we are moving. So that's why here it is minus 5. Okay. Now this is 2I1 plus 3I2 equals to 5. First equation. Okay. So with only single equation, two unknown parameters, we cannot solve this network. Is it right? So we require another equation. Okay. Two equations, two parameters can be solved. Okay. Now how do you get the second equation? Now when you are applying supermesh analysis, there we need to apply one KCL or nodal analysis. See here, I am representing. So what is the current? Here it is 3I2 current, which is same as loop current. This is I2 current, I2 current, I2 current, like this. Okay, this is your I2 current. And in this branch, what is the current? This is 2 ampere. Now what is the current here? It is I1. Is it right? Okay. Now here what I am doing, here I am applying nodal analysis or KCL. Sorry, it is KCL. So current through this current is towards node and these two currents are leaving the node. Now algebraic sum of current. See, the leaving node I am taking I1 plus I1. Okay, this is also leaving node plus 2 and this is entering node minus I2 equals to 0. Okay, I1 minus I2 plus 2 equals to 0. Clear? Now this is our first equation, and let me represent with another color. So from supermesh analysis, this is our first equation, and from KCL at node, this is our second equation. Okay, now solve these two equations, you will get I1 and I2. So how to enter these quotients? In the last class I explained, if two unknown parameters are there, you have to enter. First you have to take like this, I1, I2 and constant. Okay. Okay, now from equation 1, so I1 multiplicand is 2, I2 is 3 and constant it is 5. 2, 3, 5. So this is 2 I1 multiplicand and 3 and constant 5. And from equation 2, this I can write I1 minus I2 equals to minus 2. So what is I1 multiplicand? 1. Here I am writing equation 2. This is I1 multiplicand is 1, I2 is minus 1 and constant is minus 2. Clear? Now enter these values in calculator. Okay. So I already explained, and select your mode of operation, equation, okay, 5. So if your calculator is FX991 yes plus, then you just follow these steps. First press the mode, and here in this there are only two unknown parameters I1 and I2. So that's why for that the respective number is, first select mode. Let me go back. In equation number, the respective number is 5. Okay, equation is 5, respective number is 5, press 5. Then there are two unknown parameters, that's why ANX plus BNY equals to CN. Okay, now that form of equations are there, that's why you have to press 1. If 3 unknown parameters, press 2. Now here only 2 unknown parameters, that's why press 1. Now it will ask you to enter the coefficients A, B, C. What is, so from equation 1 this is A, B, C. Okay, you have to enter these values. So A value in first row, A2 plus 2 equals to, it will move to the next line in calculator. Now next number is 3 equals to, it will move to the next line, 5 equals to, now it will come to the second line, because now you have to enter the second elements, second equation elements. 1 equals to minus 1 equals to minus 2 equals to again equals to, then you will get x value, x equals to minus 1 by 5, where minus 1 by 5 value, minus 1 by 5, and this is minus 0.2 ampere. Okay, so x value, x is nothing but what? Actually it is I1 current. I1 current is minus 0.2. Then next, press equals to, now it, you will get y value. What is y? Actually it is I2. So now y value we got 9 by 5. So 9 by 5, the magnitude 1.8. 1.8. So like this you will get I1 current and I2 current for this kind of circuit. So this is, I have taken only simple network with two voltage sources. They are connected at the end and the current source in the middle. Now let us take one more problem. So let us take one more example circuit. Here I am taking current source same as the previous one, and one resistance is connected in series with this current source. Though you have resistor, but this entire branch, this current source is connected in between the loops. So that's why we cannot apply normal mesh analysis. So that's why here you have to apply, you have to go with only super mesh analysis. Okay, so whether that is independent source or dependent source, current source, dependent current source, if that is connected between the loops, you have to go with super mesh analysis. Okay, now let me erase this. Now try to write this equation. What is the first step? First step is represent loop current first. I1, this is your I1 current in clockwise direction, and this is I2 current in clockwise direction. First step is represent I1 and I2. Okay, then the second step is delete. Okay, so or deactivate, or else you erase this entire branch. Okay, now excluding this, if I draw that network, it looks like this. This is your figure B. By removing the middle branch, why we are removing this? There is a current source. Now this is your super mesh. See here I am drawing with a dotted line. Okay, so this is your super mesh. So you have to cover like this. So super mesh, now writing super mesh equation. It is nothing but what? Algebraic sum of voltages in loop 1, that is mesh analysis in loop 1 plus mesh analysis in loop 2 equals to 0. So together you have to apply without this current source. Now in this network 1, there are 3 resistors, 8, 12, 6. Now let me write all the voltage drops across the resistors. Left side, voltage drop across 8 ohm is 8 into what is the current? I1 current. The next element is 12. What is the current through 12 ohm? It is I2, and the next element resistance is 6, and current through the 6 is I2 again. So here it is I1 through 8 and I2 current is through 12 and 6. Left side I have written drops across the resistor. Now right side voltage sources. So in this loop, in this super loop, only one voltage source is there and the direction is minus to plus, means plus 35. So this is our first loop equation. Is it right? If I rewrite 8 I1 plus 18 I2 equals to 35 is our first supermesh equation. The next, when supermesh is there, compulsory we will get one KCL, that is Kirchhoff's current law. Either you have to apply at this node or at this node. Anywhere you can apply, you will get same answer. So now let us take here. This is, what is the current through this? With this direction, I1 current. Okay, I1, and I2 is like this, means this is I2 current. Okay, now already this current source is available. Now the direction of current is towards the node and the magnitude of current is 9 ampere. Right? So 9 ampere current is flowing in this. Now here I am applying KCL, Kirchhoff's current law. Okay, now this current is towards node, this current is also towards, now this is leaving, means towards node. If I take plus I1 and plus 9, both are towards node, and I2 current is leaving the node, so away from the node, that is minus I2 equals to 0. Now let's rewrite this equation. I1 minus I2 equals to minus 9. This is equation number 2. Now enter these coefficients. I already explained that. From equation 1, 8, 18, 35, and from equation 2, 1, minus 1, minus 9. Enter these values, you will get I1 and I2. So where you have to enter? In calculator. Then in equation form, you press 1 for two unknown parameters. So where you will get in calculator x value, where that x is I1 answer and x2 is I2. Okay, so if you want, I will try. So that is a value, that is 8 and 18, 35. Next 1, minus 1 and minus 9. So x value you will get, sorry, this is I1 or x1 minus 4.88 ampere. Then next y value or I2 value, y or I2 is 4.11 ampere. So this is your answer for the second problem. And the same problem if I take with the 3 loop. Okay, now third loop, if I take third loop with another branch, see here, same network, but here I am taking like this. So there is a loop 3 is there. Okay, I will take 3 loop circuit with a supermesh analysis. I will explain in detail. Now let us take this example problem with 3 loop. The first loop, yes. So the first step is loop 1. Here I am taking loop 1. I am representing this current with I1, and this is I2. Loop 2, I2 in clockwise direction, and loop 3, I3 current in clockwise direction. And now, so where the current source is connected, actually in between which loops? Current source, let me write C by T is nothing but current source. So 3 ampere current source is connected between where? Loop 1 and 2. So that's why loop 1 and 2, together we have to apply supermesh. Clear? Because we cannot go with normal mesh analysis. Now let us write supermesh equation in loop 1, loop 2. Now separately I will draw this. So in loop 1, first of all see the elements. So this is loop 1, like this you have to come, and here, so you have to eliminate this branch. Okay. Now in our direction 2 ohm resistance is there. I am writing 2 into, now the current is I1 minus I3. 2 into I1 minus I3. Then the second element is 4 ohm. Now this is plus 4 into, now what is the current? It is connected between 2 and 3. That's why I2 minus I3. Okay, because we are applying loop 1 and loop 2. I2 should come first, then next I3. I2 minus I3. Then next element is 8. What is the current? I2 is the current. Plus 8 into I2. Okay, that's it. Only 3 resistors. 2, 4 and 8. The next equals to voltage. So number of voltages in this loop, only one voltage, and that voltage source is minus 2 plus, that's why it is 6 you have to write. Now rewrite this equation. 2I1 plus 4, it is 12I2, and then next minus this minus 2I3, minus 6I, minus 6I3 equals to 6. Let me erase this. Minus 6I3. This is our equation 1. Okay. Then next in loop 3, we can apply normal mesh analysis. Okay. Now in this only 3, all are resistors, that's why there is no voltage source. Now I am writing the first element 2 into, now the current is I3 minus I1. Then this current, the current through this 2 ohm resistance is I3, 2 into I3. The next element is 4. Now 4 into I3 minus I2. 4 into I3 minus I2. Is there any voltage source in loop 3? No. So that's why equals to 0. Okay. Now rewrite this equation. Minus 2I1 minus 4I2 and I3 are 8 plus 8, I3 equals to 0. Here we got equation number 2 with normal mesh analysis. Now there are 3 unknown parameters. Then how do you get third equation? So when supermesh is there, we have to go with KCL. Okay, one more equation you will get with KCL application. Now let me take blue color. Now where the current source is connected, here the current source is connected, that's why I am applying KCL at this point. Okay, we should not apply KCL at this point because exactly we don't know what is the current, because it is connected between loop 1, 2, and here it is in between loop 2 and 3. We don't know exactly what is the branch current here and here, that's why we should not apply KCL here. Here we can apply because exactly what is the current through this branch? This is I2. And what is the current here? It is I1. Now what is the current here? It is in this 3 ampere. Now this current is I2 towards node. This current is 3 ampere towards node, and now this current is leaving the node I1. Now apply KCL at that node. Now taking towards current. I2 is toward, that's why plus I2 plus 3 ampere is also towards node plus 3, and I1 current is leaving the node, that's why it is minus I1 equals to 0. Okay. Now if I write this, first I1, then next I2 minus I1 plus I2 equals to minus 3. Okay. Now 3 equations, 3 unknown parameters. Now see in calculator how to enter I1, I2, I3 and constant. Okay. So in calculator you have to remember that this is AN, AX, ANX, AX plus Vy plus C equals to D. So these values we are entering. So from equation 1, so where is equation 1? This is our equation 1. What is I1 multiplicand? 2, and I2 multiplicand. What is I2? This is 12. Okay, 12, and I3 minus 6, constant plus 6. Then from equation 2, this is our equation 2. So now I1 multiplicand minus 2, for I2 minus 4, I3 it is 8 and constant 0. Then from equation 3, so this is our equation 3, I1 multiplicand is minus 1, I2 multiplicand is 1, I3, do you have any I3? No I3, means 0 I3. Okay, and constant is minus 3. So enter these values in calculator and you will get I1, I2, I3. So go to mode of operation, select press 3 and five equation. For equation it is 5, 3 unknown parameters, press 2 because A n, B n, C n, D values you have to 2 equals to 12 equals to minus 6 equals to 6. First row I entered, then second row minus 2, minus 4, 8, 0. The next third row minus 1, 1, 0 and minus 3. Now press 2 times equals to, then you will get answer x value as x equals to I1 current. How much it is? 66 by 19. The value 3.47. 66 by 19, it is 3.47 unit, current unit ampere. The next y, for y value, press equals to, it is 9 by 19. 9 by 19. What is, how much it is? 9 by 19 division 0.473 ampere. Then next for third one, that is Z value. In calculator it shows Z, but actually what is that Z? I3 current. It is 21 by 19. 21 by 19 in calculator. If I press ST, it is 1.10 ampere. So this is how you have to solve your network with the 3 loop if any current source comes in between the loops. Okay. So this is about our lecture number 7. The topic we finished supermesh analysis. You have to remember, if any current source comes in between the loops, you have to apply supermesh, and you will get one KCL nodal KCL application when supermesh is applied, where the supermesh is applied. Okay. So with this we finished the supermesh analysis. In next lecture we will discuss nodal analysis, which is an application of Kirchhoff's current law. So thank you. You please practice a few more problems. So we will see in next lecture 8.